Hi, hello everyone. Welcome to Guide My Career. This is Siva from Department of Meteorology and Oceanography, Andhra University. So far, we have discussed about three different kinds of resolutions like spatial, spectral, and temporal. So in this video, we are going to talk about radiometric resolution. So most of the people would know more or less clearly about those three resolutions like spatial, spectral, and temporal. But coming to the radiometric resolution, some of might have some doubts like what is this radiometric resolution and why do we measure especially in bits, and this kind of doubts some of them might have regarding this radiometric resolution. So don't get worried, by the end of this video I will make you more clear about what radiometric resolution and why do we measure this in terms of bits and all. Okay, so first let's see what is the definition of radiometric resolution. See, the radiometric resolution of a sensor is a measure of how many gray levels are measured between the pure black to the pure white. That is the depth of the color. Okay. In other words, I can say it is an sensor's ability to discriminate or distinguish even small differences in the reflected or emitted energy within the ground area, which is equal to pixel of image. Okay. That means radiometric resolution is something which tells about the sensor's ability to clearly distinguish or discriminate the more number of shades in a color. That means, for example, so for suppose you have an image, right? And as you already know that the whole color of this image is made up, whole color of the image is ranging from the pure black to pure white only, right? The whole color of the image is lies between the pure white and black, right? So the point is with how many shades or gray levels between the black and white the image is made up of. That is the point, right? If you see the first image, this image is made up of with how many gray levels between the pure black and white the image is made up of? Simply two levels, right? If you see the whole image, either you see whole black and whole, I mean black color or white color, only two colors. That means the image, whole image is made up of two gray levels between the pure black and white. Similarly, coming to the second image, this image is made up of the four gray levels between pure and black, pure black and pure white, right? In second image, this image is made up of the two gray levels, sorry, four gray levels between pure black and pure white, right? Similarly, in third image, if you see, this image is made up of the 256 gray levels or 256 shades between pure black and white, right? With 256 gray levels or shades between pure black and white the image is made up of, right? Why I am saying number of gray levels between pure black and white all these images made up of, sorry, all these images are made up of, since we are talking about the radiometric resolution, right? The radiometric resolution is something, as I told, which tells about the ability of sensor to detect or to clearly distinguish number of gray levels between the pure black and white, right? Since we are talking about, in this case we are talking only about the black and white image, that's why I'm saying number of gray levels or number of shades between the pure black and white, right? For suppose you have a two sensors, right? One sensor can detect the only two levels between pure black and white, and another sensor can detect 256 gray levels very clearly, each and every level of 2 to the power of 8. That means 256 levels can be clearly identified by the sensor between pure black and white. Then which sensor will have high radiometric resolution? Obviously one which has high gray levels or shades between pure black and pure white. Okay, that's what I'm trying to say is radium. When somebody asks you what is the radiometric resolution, what should you understand and what should you say is radiometric resolution is something which tells about the sensor ability or capability to detect or to discriminate number of the gray levels between the pure black and white color if it is a black and white image case, right? Similarly, if it is a colored image case, as we know, as we already know that the colored image is made up of three prime colors like RGB, red, green, blue. So how best, I mean how your sensor can, I mean in case of colored image, simply instead of the only number of gray levels between pure black and white, in colored image case number of gray level, I mean number of shades in uh, all three colors, number of shades in red, number of shades in green, number of shades in blue to represent the color image, right? As you see like this levels, number of levels, when your sensor has a capability to distinguish or clearly identify each and every level of the color between the pure black and white, then it means as the more number of the gray levels or shades between pure black and white your sensor can detect, then your sensor has a more high radiometric resolution, we can say, right? That what I'm trying to say finally or ultimately is radiometric resolution is something which tells about the sensor ability to detect or to clearly distinguish the number of shades or number of gray levels between the pure white and black if it is a black and white image. Similarly, number of shades in red color, number of shades in green color, number of shades in blue color if it is the colored image case, right? And what about, and one more thing, I also mentioned that radiometric resolution is measured in bits. Why do we measure in bits, and why these levels are coming? Like when I say a 4-bit, the number of levels are 16. When I say 8-bit, the number of levels or shades 256. How these levels are coming when I say radiometric resolution of sensor is this 8-bit or 4-bit like that? Simply the each bit in sensor, each bit records an exponential power of the 2. That means if I say radiometric resolution of the sensor is 1 bit, 2 to the power 1 equal to 2. Similarly, if I say 4 bit, 2 to the power of 4 equal to 16. That means the sensor have a capability to distinguish 16 different levels between pure black and white. Similarly, in case of RGB, 16 different shades from each and every color, each color of each these three colors like red, green, blue. 16 shades in red, 16 shades in green, 16 shades in blue, like that. Similarly, if I say the 8-bit, that means 2 to the power of 8. That is equal to 256 gray levels. If it is a black and white image, 256 different gray levels that can sensor clearly distinguish, right? Similarly, in colored image, 256 shades in red, green, blue, 256 shades in red, 256 shades in green, 256 shades in blue, like that, right? So that's how we measure generally radiometric resolution in terms of bits. As the bits indicates the exponential power of the 2, that is equal to number of gray levels that can sensor can detect very clearly from the reflected energies from the different features on the ground. Okay, so this how the finer the radiometric resolution, more number of the gray levels that system can record, and hence more detail can be captured from an image. Means as you're increasing the number of gray levels, that means you are increasing your radiometric resolution in terms of the bits. That means you are increasing the amount of detail that can be captured from an image. See, from this image you can very clearly say that, okay, in first image you are unable to say anything which is okay, exactly is this, like this is exactly a cloud, this is exactly a man, like that you are unable to say. But as you are increasing your radiometric resolution in terms of the number of gray levels by increasing the number of bits in sensor, you can able to say, see, okay, some people are standing here, you can say this information from this image, and you can say that some snow or some snowfall kind of thing is happening, or the some hill and mountain, like that. See, but in from image, this image you are unable to say any information, right? This is how, as a number of as you are increasing your sensor radiometric resolution, you can say even minor details from the ground very clearly, okay, by the reflectance energy from the different features on the ground. Okay, and why do we need to increase radiometric resolution in terms of bits, like from 3 bit to 6 bit, 6 bit to 8 bit, like that? Why need to increase? What will be the what something else newly come when you increase the radiometric resolution from this bit to that bit, from 3 to 4, 4 to 6, 6 to 8, like that? For example, I have mentioned here one case when one system, for suppose there are two sensor, one can use the 3-bit radiometric, one can has a 3-bit radiometric resolution, one has a 3-bit 6-bit radiometric resolution. In both cases, what will happen? See, in actually, so in 6-bit, see, a 6-bit system could record the difference in the energy at the levels 45 and 47. But see, if I'm saying like 2 bits, 1 bit, 2 to the power 1 equal to 2 levels. If I say 4 bit, 2 to the power 4, that is 16 different levels, means 1 2 3 4, like that, up to 16, right? Like that, if you see the 6th bit sensor, that means it is the energy at the levels, the energy level at the 45 is something different from the 46. Similarly, energy level at the 46 is something different from the 47. Okay, there is a little bit difference, right? But if you want that difference in a 6-bit system, I mean in a 3-bit three-bit sensor, do you able to get? You unable, because see, if you equally equally I mean if you equally distinguish, if you equate the 6-bit system to the 3-bit system, you see, ninth 9 value energy at the level 9 is equivalent to 1, similarly 18 at 2, like that, right? But in case of, if you want to measure the difference between the energy levels at 45 and 47, it is possible with 6-bit system, since it has a separate energy level at 46, 45. The sensor could sense the recognize the energy at the 45 level as a separate, and 46 level as a separate, 47 as a level as a separate. Means you can, if there is any difference, you can sense, right, in 6-bit system. But in case of 3-bit system, what will happen? Both, whereas in 3-bit system, what will happen? Both, I mean 45 energy at levels 45 and 47 will be recorded as a only 5 only. At that moment, what will happen? Whatever the difference between whatever the difference at energy, whatever the difference between the energy at 45 and 47, that difference will be missed in this 3-bit system, right? This is how, as you increase the number of bits, you can, for suppose, even more 45 and 47, even some minor difference are there. So you want to capture those differences, then again you simply need to increase the number of bits from 6 to 8. Then if there is any minor differences between still 45 to 47, it might be something, some other number, some other number will be, like within that you can see some difference, like that. As the number of the bits increases in terms of radiometric resolution, you will get to know some in detail information regarding any features on the ground, right? So for an idea, I have mentioned some of the and one more point I want to say, that as you are increasing the number of bits in terms of radiometric resolution, your volume of data will also get increased, since sensor records the those many number of shades for each pixel of image. If you see the each pixel of image, it records the those many shades. For suppose, if I say the radiometric resolution of a sensor is 2 to the power 8, that is equal to, it has to record, it has to clearly distinguish the 256 shades in a color, right? That means for each pixel it has to distinguish the 250 shades in different reflected energies from the ground, right? Like that, as it is recording the 256 shades for the each pixel of image, in such a way the volume of data will also get increased, right? So like this, you will come to know different information, nice information regarding different features, in detail information, when you increase the radiometric resolution. And this table shows you, for an idea, I have mentioned some of the satellites which use the what is the radiometric resolution of those satellites. Like if you see Landsat thematic mapper, radiometric resolution is 8-bit. If you see the Nova AVHRR, the radiometric resolution is 11-bit, like that. That means 2048 levels, like that, right? And as I already discussed about this, how best we can say it, this is one of the image which shows you, like how best we can get the information from different image, I mean images, when you increase the radiometric resolution, like you see. So I have already talked about this image, right? So this is how, when we can know different informations, like different features from the ground, when you increase the radiometric resolutions. And this is like I can say, it's an overview regarding the whatever the remote sensing resolutions we have discussed so far. In this image you see different resolutions. On the right side of this image you see the radiometric resolution. On the left side of the image you see the temporal resolution. Similarly, on the top you see, sorry, on the top you see spectral resolution, and then bottom you see the spatial resolution. And you see different satellites and different remote radiometric resolutions. Like this image shows you like an overview regarding the whatever remote sensing resolutions we have discussed so far. Okay, this is all about the remote sensing resolutions. I hope I'm able to explain about all these remote sensing resolutions in a way you understand. For any queries, if any suggestions, if you want to mention, please do let me know, and mention your valuable suggestions and comments. Okay, and I sincerely thanks to some of the sources to get some detailed information and valuable information regarding all this, like remote sensing and image interpretation by Lily Sand and NPTEL, like Google, YouTube, and Natural Resources Canada. These are some sources I used to make this presentations and videos and all. Thanks to all of them. And this is all about remote sensing resolutions. Okay, thank you.